This is Terry, and in this video we're going to quickly show you how to set up a Modbus master connection from your SIM to a connected device. Now, Modbus is a pretty old protocol, but it works pretty well, and the original Modbus could move bits and 16-bit values back and forth. And we with the Daniel extensions, have extended that to be support byte, 16-bit word, or 32-bit word, float, and strings. And strings is not a Daniel extension, that's our proprietary extension, but we can support moving all those data types back and forth. Now, there's some disadvantages to Modbus. Modbus is a lot trickier to upgrade firmware over the wire. It's a polled protocol, so whoever's the master has to poll the slaves for their values if it wants to get new versions from the slave. So as a result, the master can push values to the slaves. So if the GUI is the master and you press a button on the GUI, it will instantly push that data, that change, out to the slave, the target slave, potentially. But if the slave has something happen, like a door open, door close, it will have to see the next poll time before the master, the GUI in this case, will see that change. So there can be a little latency in seeing slave events. And that's the challenge with Modbus being master-slave. The bridge protocol, which is much more sophisticated than Modbus, is a serious proprietary protocol, and bridge supports push in both directions as well as optional polled for lower priority messages. So there are a lot of advantages to going bridge, but we're going to talk about Modbus Master. And Modbus is a great old protocol, as I said. If you go to simplymodbus.ca, it's a great site to explain Modbus. They've got some cool tools for not very much money you can install on your PC, and you can sniff Modbus packets. The folks from that make the Beagle analyzers, you can actually connect up to a UART and watch Modbus packets. So there's lots of ways of sniffing Modbus on a line. And a Modbus slave was designed to run in a sensor, in an 8-bit processor. So it's really just a switch statement, a few protocol things on top of a UART. So it can be implemented in a very small processor like a Renesas RL78 very efficiently. So there's a lot of good reasons to use Modbus. It's simple, it's cheap, it's easy, and a lot of people have it. So how do we create a Modbus master in your GUI? So let's go create a new project for the 231. Let's call it Mod Master Demo, and we'll create a very minimal GUI and say go. Alright, so here comes our GUI page, a very minimal GUI. It's just got a logo in the middle of the screen. Now, like all communications links, you start off by creating the link in the resources area. So let's go into the resources area. There's nothing in this links section. Let's create a new link. Now, a link is a binding of a protocol to a port. In this case, we're going to use the UART coming out of the SIM, which is a 3.3 volt level TX-RX full duplex UART. And we're going to bind it as a Modbus Master RTU. RTU is binary Modbus Master as opposed to Modbus Master ASCII, which is less efficient because it's human readable. It's got colons and characters and all that kind of stuff. If you're debugging, Modbus Master ASCII is pretty easy, but it's really a pain to write the slave side for a Modbus ASCII slave or a master slave. The binary is a lot easier. So we're going to use Modbus Master RTU, and if you have a good packet sniffer for Modbus that's as little as 59 bucks on your PC, you can actually sniff these and it'll break them apart and show you how the packets are constructed. Now, we'll give it a name. We'll call it my bus. Okay? Now that's my link. Okay? Now that's my link that's binding the Modbus Master protocol from the GUI's perspective to channel 0. Now, because I'm a master, I can have lots of slaves out there. I can have 10 sensors and 2 other devices. I can have lots of slaves. So I have to create what we call a link set to say I want to identify a slave out there on the network. So if I've only connected point to point to another microprocessor like a RL78 or maybe a PIC32 or a PIC18 or something like that out there, I'm just going to create, and maybe that's a lighting controller. Okay, so my controller and it's got ID number 1 because all slaves have an ID that's unique, 1, 2, 3, all the way up to 255. So I've got a link that's my UART bound to Modbus master RTU protocol, and on that link I know I've got a slave out there with ID number 1 that identifies a device out there on the network. And then within that device has to be written to understand queries, requests, and either sets or gets. So in the Modbus protocol we have sets and gets, and the standard Modbus protocol allows you to have bit or word, 16-bit word. So we're going to create a link variable. It's going to be a short, and it's going to be an output. Okay. So what that is a 16-bit signed 16 output value, and we're going to give it a name, and we'll call it light on, like that. And we're going to, every Modbus variable on a controller, on a device, has an address. Now, different devices can have the same addresses because that's within the context of the device. So let's say that that's, and they're 16-bit values, unsigned. So in this case, it's let's just create this short. Now, in your slave protocol driver, you're going to have a big switch statement, and you're going to say if the ID is 1, oh yeah, that's light on. If the ID is 2, oh, that's whatever else it is. And all you're doing is mapping these IDs to knowing what they are. Okay, so in this case, light on is a short output from the GUI to the controller. Now, I'm also going to want to add a new link var, and I'm going to say it's an input. And this is, let's say this is a, on your lighting system you have a wall switch. Wall switch. And that, well, in reality, these aren't shorts. These are Booleans. So I'm going to make these both Booleans. And we'll call this switch. And we'll call this light. There we go. And the switch is an input, and we better give it an address, let's say 0002. Okay, this is an input, that's an output. Alright, so what I want to do is I want to, when you turn on the switch, which is out on that controller, that switch is not controlling the light directly. It's coming back to the master here, and then the master is telling the light to turn on. Because the switch, you know, we could actually have a second controller out here, which is the switch. So actually, let's just do that. Let's create a link set. We'll call this my switch, and it'll be device number 2, and we'll change this to be my light, and it's device number 1, and this is going to have a let's call it state, and we're going to take this switch variable and we're going to move it over here into this thing. We'll call this the state. So they both have something called state, and this one has address 1, and we can actually make this address 1 too. So imagine you've got a smart wall switch out there, and it's got a physical switch connected to a little microcontroller that's got a little Modbus slave stack on it, and when the switch is turned on, it says this value of thing number 1, which is a Boolean, is true, and I've got a light out there that when I set this output to true, the light goes on and false is off. And I want to connect it together, not even to the GUI. I just want to run this thing through the GUI. And have the GUI manage my lighting system. So what I can do is I can add a new listener, and I can listen to my link dot my switch dot state. So whenever the state of this switch changes, in other words, whenever I get a new value of the wall switch, that Boolean variable at address 1 inside the switch, whenever I get a new value, this listener will wake up. Then I'm going to add a new script, and this script is going to do something interesting. My link dot my light dot state equals my link dot my switch dot state. Okay, so what that's doing is saying whenever the switch changes, run this script, and in this script I'm going to say make the light's state, the output variable, the same as what I got for the input. So if the switch is on, I want to make the light go on. If the switch is off, I want to make the light go off. Make sense? So that I have looped the wall switch to the light. Now the problem here is one of the masters. It's the master-slave problem. Okay. Now in this case, the light, when I set my light.state to true or false, and let's say instead of using the switch, I wanted to do it with this button. In other words, I press the Sirius logo, and the light goes on, I press it again and the light goes off. So in that case, I'm going to go to the logo and I'm going to turn this into a button by adding a listener to the touch panel. Touch 0.event.e, and I'm going to say touch 0.event.e equals touch.dn. Actually, okay, well, I won't complicate things. And then inside the script, add a new script. I'm going to say mylink.mylight.state equals not mylink.mylight.state. So I'm inverting it. So whenever I touch this button, the light will turn off or on, alternating. So in this case, because this is a Modbus, I'm a Modbus master, I've configured that's my protocol. Whenever I change the value of an output, it pushes that value to the slave immediately. So whenever I change mylight.state, it'll push the new value out to that slave. And that push is a packet with a little slave ID number 1, because our mylight was slave ID number 1, with a address number 1 and a Boolean value of 0 or 1. So there's a little function code, and that the Modbus protocol is pretty simple. And you crack that packet open in your little protocol handler, and then you set your local variable, or you call a function to turn your light on and off. Easy to do in a little 8-bit micro, certainly easy to do in a 16-bit micro, and a 32-bit can do it with its eyes closed. Now, the problem is, how do I get those inputs, right? So, because I'm a master and the switch out there just went, somebody flipped the switch. Well, the master doesn't know that. The switch can't send data to the master because the switch is a slave. The master has to poll the switch periodically. So, there's a couple ways to do it, but I'm going to show you the simple way and a very straightforward way. We're going to use a timer. And I'm going to do this very straightforward. So what I'm going to do is I'm going to set up a timer. Add new timer. So a timer is a little periodic wake-up timer. And I'm going to create this with a value of 5, which means 5/10 of a second every 500 milliseconds. And I'm going to make it a one-shot true, auto-reload true, period. So when it reloads, I want it to reload with a period of and I'm going to make it enabled. So when it comes up, it's going to be automatically clicking away. And I'm going to create a listener underneath that, add new listener. And it's going to listen to the timer.alarm. So when the alarm goes off, and I want to know when it goes off, timer.alarm, when it changes and it goes true, I'm going to run a script. And this script is going to do a couple things. First of all, it's going to, now if I just had a manual timer, I could do this. Timer.value equals timer.period. That would reload the timer value. I could say timer.alarm equals false to clear the alarm. And then timer.enabled equals true would start the timer again. That's kind of a manual timer. And that's really easy to do, right? You can get fancier. If you look for timer on our document website, you'll find a really great description of all the different modes of timers. But we got an event, we woke up. Now, how do we get the master to go ask all the slaves for the things that are inputs? And the simple answer is you use something called refresh. So you say mylink.myswitch.refresh equals true. Now notice that that's on the link set, my switch. I didn't bother with my light because there's no inputs on my light, it's an output. But my switch has an input called state. This will tell the system, ship GUI under the covers, to go poll all the input variables on my switch. And when they change, it will generate an event and cause these things to trigger. So that's the whole, oh, I did something wrong here. My link, we switch. Oh, I don't know what I did wrong. So basically, this is designed to poll. I goofed up the timer.enable. What the deal is here? mylink.myswitch.refresh equals true. That looks right to me. Okay. And Oh, I'm doing something wrong with the timer. Oh, enabled. That's what's wrong. See, I'm goofing it up. So I do need a timer.enabled because I do need to reset. I do need to restart the timer. So here we are. Timer.enabled. Sorry about that. Equals true. There we go. It was flag. It was telling me the right thing. You see, it's colored wrong and there's an error. So timer.enabled equals true. Okay. So the refresh property, what it does is it tells the Modbus system under the covers. Oh, I've got a bunch of these things open. It tells the system to poll all the input variables. So it goes out and sends a packet from the host to the device, the master to the slave, and says, give me the value of address 1. Address 1 returns that value, which is the state of the switch. You do that in your switch statement, and you say, oh, go get the value of the switch and return it in the packet. When that comes back, if this changes, state changes, it will wake up that listener and call that script. So here's a simple GUI where we have an input and an output variable. We're polling the inputs, we're pushing the outputs, and we actually have two things. The input is controlling the output directly through this listener right here, and we also have a little logo button where we can turn it and change an output. Now you can get a lot more sophisticated than that. You can go in and in the new version of SHIPTide, you'll see coming soon you'll have these other variable data types other than just short and Boolean. You'll have string and all these other things. So go to our website, go to SiriusIntegrated.com/docs, and in that document website, so let's go to SiriusIntegrated.com, let's just go straight to the docs site, and in the docs site you can go and just search for Modbus, and you'll get a great description of Modbus. There's some references, there's protocol modes, and you can learn a lot more. Okay? Hope that helps. That's a long video. I apologize for taking so long, but hopefully that gives you a good grounding on how the communication system with Modbus works and how to set up a link.